Run IRSSI, which is a tremendous insect. In this screen, that's not good.
We're going to talk for about 5 or 10 minutes first.
Okay. Do you want to use the mic?
No.
Okay. I'll hang out here. Part Android. That's fine. They have chairs here.
I'm running on.
Spam wrapped in an anchor tag. And you just open the terminal. If you don't need all those things, you should have them. And especially with the anchor tag run in different functionality.
Maybe on the first floor.
Python. We're so happy to have you. Here. Welcome. Thanks for coming. We run at least 2 styles of event every month. One is like this, it's sort of lecture-based, sitting in rows. We also have an unstructured project night, where you come and you eat some pizza and you work on whatever you want in the company of fellow Pythonistas. That's a really great opportunity for people of all experience levels to get together, get help, get inspiration, work on new projects. Let's see here. Some logistical stuff. So we're going to
just this one.
Bathrooms are.
Well, I haven't looked in there.
The pizza is in the back.
Okay. Talk to Mali. He's the guy doing video and sound and such. You want me to do this?
The Wi-Fi info is going to be cycling through. The secret is be on the Cambridge network.
Or you could just turn one on.
For Boston Python
and pass it to it.
So you can
Oh, and
all
that
these
goes to the
guests.
speakers.
Okay.
Let's see here. Other.
Just check it first.
Yeah, awesome.
So originally, because it's 2 days before Halloween,
Sure.
Jessica complained that
No, no.
she said she was going to come dressed up as a generator and hand out values. She didn't do that, but
Just
this
let
is
them know
my
that they're right here if they need
Python
one.
Okay.
costume.
He needs one too. They're right here.
I am
Okay.
there as a fight code.
Mallory, do you want me to wear this or use one of the hand
In my
mics?
defense, I was a last minute.
You should still wear that because that is what goes in.
Okay.
We do have some decorations though. We have some very scary spider webs decorating the desk up there.
Bug. They're bugs.
So some sort of non-local community announcements. So PyCon, which is the largest annual PyCon conference, is happening in Montreal in April of next year. And tickets are on sale for that. So if you would like to go, and in particular, the early bird tickets are currently on sale. So if you think you're going to go to PyCon, you want to go on the cheap, now is the time to buy tickets. There's a fixed number of early bird tickets that are half out. So if you want to go to PyCon, you should definitely buy tickets sooner rather than later. If it's the kind of situation where your business needs to approve the time and yada yada, you should start that process now because PyCon always sells out. I'll be there, Ned will be there,
Definitely.
Everyone's going to be there, it's going to be really fun.
All the cool kids will be there.
As cool as you can be.
When you're in programming language.
It's a really fun, volunteer-driven conference. It's appropriate for people of all experience levels. Beginners, you'll have an awesome time there. Advanced folks, you'll have an awesome time there. PyCon is truly a great time.
Right, and there's a really great lineup of talks, some of which have been proposed by Boston area speakers. We're going to have rehearsals for them in February and March. There are some great keynotes, including one by Jessica. So you should totally go to Montreal for PyCon 2014.
Thanks for the plug, Ben.
Sure, no problem.
And then if you'd like to submit a lightning talk for PyCon, the proposal that passed.
That passed. Poster.
You can still submit a poster for PyCon. The deadline is sometime in the future, I think far away. Anyway.
No, it's like 2 or 3 days away.
If you'd like to submit a poster for PyCon, you should definitely check the deadline today to see who's going to make it. Excellent. I think that's it for community announcements.
I guess so. Yeah.
Okay. Pizza?
There's pizza in the back. Pizza in the back was bought by Red Hat. And Mike here? I'm sorry? Langdon, sorry.
Mike is at EclipseCon in Europe.
Oh, well, lucky Mike.
Yeah, well,
Good for him.
So I'm Langdon. I don't usually use the mic, but I'm kind of a developer evangelist for Enterprise Linux at Red Hat. And just to kind of go with the pizza thing, something we found, everyone found last week, check out bit.ly/rh-pizza, and you can see really, truly Red Hat pizza. As most of you probably know, Red Hat and Fedora really love Python. Which you may not know is OpenStack also really loves Python, as does OpenShift. All things that we're pretty heavily involved in. And you know, these cool little cards, if anybody wants to see them, and kind of have some links about what they do. So, you know, we're always hiring Python people, so definitely check out jobs.redhat.com and you know, contribute to open source, because that's what we really like.
Awesome.
Thank you. Totally go work for Langdon. Yeah. Anything else to do? No. So there will be drinks at Mead Hall afterwards. We'll be done here by about 9. We'll head over to Mead Hall. We have some free drinks. We'll tell you a little bit later who and why did that. And now I think we're ready for our talk.
Awesome.
Okay. So we have 3 talks tonight, and the idea tonight, it actually started with David's idea for his talk, and I realized that there were other talks like it alongside. And the idea is that when you're building a system in Python, you often don't get to stay purely within Python. You have to use other languages alongside. And those languages that we're going to talk about tonight, and give you a quick introduction to them at least, are SQL for talking to relational databases, CSS and HTML for putting nice-looking pages in web browsers, and regular expressions for doing text pattern matching of all kinds.
Information very quickly. There are basically 2 different types of databases these days. There's SQL databases, and there's NoSQL databases. And I put together this rough comparison. Basically, SQL databases are more powerful, they have more features, but NoSQL databases, because they have fewer features, can sometimes be simpler and faster to get started using. I'm not going to be going into NoSQL databases in this talk, so I'm just going to be focusing on SQL databases. SQL stands for Structured Query Language. It's basically how you talk to a database. I don't know what's wrong with this guy. Apparently, he doesn't really know how to do so very well. But it's actually not that hard to do so. So this is an example of a real SQL query. It's basically 3 statements. There's select, from, and where. And it reads almost like a piece of English. So that's almost kind of similar to Python, which is also almost kind of English. So this is another reason why I figured why this would be a good venue to talk about SQL. So the fundamental idea behind SQL is we have tabular data in our databases. In NoSQL databases, the data can be in any number of different structured forms. Some records might have lots of pieces of information. Some records might have very few pieces of information. SQL databases are relational, which means that all the data has to be related to each other. And for that to work, you need to have records where every single row has the same number of fields in it. So for example, this is a very simple example of a user table. We have 5 different users. And there's also a field in there called active, which is a simple Boolean. Another thing to note is that it is possible to have fields that don't have any value. So for example, share has no last name. It just doesn't exist. So in SQL databases, you use the value null to represent, I don't know what this data should be, or there is no data here, or generally a lack of data. So that's how you work with pieces of data that don't quite fit into whatever table that you're defining. Use null for the values that don't really seem to slot in correctly. The other thing to note is that the data is unordered in a table. So I have exactly the same data here, organized differently. It's actually where is optional. If you leave it off, the database will simply return to you all of the values in the table that you're interested in. It won't filter them at all. I've also shown here an example of select star, which is just a shortcut of saying, I want every single column in this database. So give me the ID, the first name, the last name, whether it's active, all of them, whatever they are. Also, the as keyword is optional. It's just an alias. It gets helpful when you're dealing with multiple tables in the from section. And if the column names are not ambiguous, which is to say, if you have different columns in all of the tables in your query, you don't need to tell the database which column is from which table. It's smart enough to figure it out. So this is exactly the same query. It's just a little bit shorter. So the first thing I want to talk about in detail is this where clause. That's the filtering part of the query. And that goes into how you can figure out which rows you want returned from the database. Because most of the time, you don't want every single piece of data in the database. You only want the pieces of data that you're actually interested in right now. So you can use basically any sort of comparison in order to do that. Databases can understand many different types of data: string, numbers, dates, true and false. And you can do greater than, less than comparisons on them. For strings, you can even do substring matching. So you can say, give me all the strings that contain in in the string, and that will return to you all sorts of substrings like that. There are various different ways that you can compare with the where clause. Also, as I said, null indicates a lack of data. So when you're doing filtering and comparisons, you need to be aware that databases handle null sort of as a special case. If you're looking for example, all numbers less than 10, you might expect null to roughly equal 0, but it doesn't. 0 is a value. And so the database won't return to you null if you say all numbers less than 10, because it doesn't know what number it is. So you can specifically say in your where clause, I care about the rows where this column is null or this column is not null. You can also have a query that has multiple different where clause all chained together. And you can use and or to do that. So for example, if you're interested in all of the knights that seek the Grail and their favorite color is blue, then this query will give you only those knights for whom all of those 3 conditions are true. If, on the other hand, you're interested in all enchanters and all people who are named Tim, then the second query will give you both results. It will also include the enchanter whose name is Tim, but it will include all enchanters whether or not their name is Tim. Also, as I said, data in a SQL database is not ordered by default. And the reason for that is because a database could potentially contain a lot of data. To give you an example, the Library of Congress. There is a database that contains every single book in the Library of Congress. It's even possible to have databases that contain every single word of every single book in the Library of Congress, and need to be able to return data from a query saying, I need to know which page in which book this sentence appeared in. So as a result of that, databases can store their data in very strange ways to facilitate basically being able to answer any sort of query that you can possibly imagine, and to be able to do so quickly. And as a result, it will return the data to your query as soon as it finds it, not necessarily in any discernible order, unless you want there to be an order. And for that, you use the order by clause. So for example, I've got the same set of data here, except by including this order by, I have it being returned in order by ID. You can order by whatever column that you want. So here I have it ordered by name. And you can see that the IDs are out of order, but the name is in order. You can also order either ascending or descending. If you don't specify, then it assumes that you're ordered ascending. But you can specify either way, and moreover, you can also specify multiple different orderings. So if you care about, let's say, the number, let's say you have a telephone book ordering, where you order first by last name and then by first name. In the cases where many different people have the same last name, then all of those people are returned in the query in order of first name alphabetically. So that's a case where you'd have multiple different orderings in a single query. So all of these things that we've gone over so far, select, from, where, order by, pretty straightforward. Joins are the real power of SQL, but they're also kind of tricky to understand. And this is where a lot of people get scared about SQL. So I'm going to try to take this slow, because once you understand how joins work, then you're going to understand why databases are really cool and how you can get some of the real power out of organizing your data in a database. So let me take an example here. We're starting up onlinestore.com, and we want to build a database because we have lots of pieces of information that we want to keep track of. We have customers, we have items, we have orders. Each customer might have multiple different addresses that they want to ship the items. This is called a one-to-many table relation. And the way that we set this up is we give each table an ID column, which is usually an integer. Most of the time, the database can actually handle this integer for you. So you don't even have to specify the ID of whatever value you want to stick into the database. The database will just assign to that piece of data whatever the next available ID is. So usually they go, ID number 1, ID number 2, ID number 3, and so on. The value doesn't matter. What matters is that it's unique in that table. And then in the second table that relates to the first table, there is a corresponding column that has a pointer to a row in the first column. So for example, you can see that ID number 1 in the address table is 1 Main Street, which has customer ID number 1, which means that that address belongs to Frank. We can see that Frank actually has 2 addresses, 1 Main Street and 11 Cambridge. And we can see that Joanne is at 98 Myrtle Avenue and also apparently lives here at the Nerd Center. I don't know how that works. And the way that we join these pieces, we can see that, for example, Frank placed an order on the 23rd, and in that order, he got the first 3 items in the order item table. And those items are 1 hammer, 12 nails, and 1 toaster. I don't know why he ordered those things, but that's onlinestore.com. It contains the most random stuff you can imagine, apparently. So you're looking at these 4 different tables to contain some information that's conceptually rather simple. And you're thinking, why the hell are we taking all of this effort to organize the data in many different pieces when we're just going to put those pieces back together? What's the point of all of this shenanigans? Why are we breaking these things out if we're just going to put them back together again? And the reason is because the power of SQL joins allows us to do all sorts of interesting queries and to find out information to questions that we might not even know that we're curious about right now. So for example, if we want to know which items people named Santa bought in December of last year, we can join on all 4 of these tables, tell the database that we're interested in the names of all of these different items, specify the linkages between the various different tables in the relation, and indicate that we want the customer name to be Santa, we want the order date to be between December 1st and December 31st. And this query will return to us a list of rows of the name of every single item that matches our query. What if we want something similar but slightly different? What if we want to find out how much he spent? That query is almost identical. The only difference is that we're returning a different piece of information from that massively joined table. SQL even has operators like sum or count, which can take many different pieces of data and coalesce them all into one value. So we can sum up all of the different prices of all of these different items and find out how much was spent in total. What if we want a completely different query? Who bought the mongoose? This query does another join and simply specifies that we want the names of the customers who bought the items whose name is mongoose. This is a case, by the way, where the column names are not unambiguous. If we simply said select name, then the database wouldn't know which name we meant. Is it the name of the customer, or is it the name of the item? And so that's why I have to specify select c.name, because c is an alias for the customer table. And so this shows how to organize the data in a way that makes it all related to each other and allows you to specify all the different linkages between the different tables. Effectively, a relational database allows you to slice and dice your data and, as I said, answer questions that you might not even have thought of yet. If you're familiar with a non-SQL database, one of the major differences between that and a SQL database is you have to know in advance all of the questions that you are going to be asking your database. Because if you don't tell your database ahead of time that you're interested in a specific query, and then you ask that database how to find that data in a way that it didn't expect, a non-SQL database will not be able to answer that question for you because it doesn't store data in a way that allows it to slice and dice it. But a relational database, you can throw your data in and all sorts of questions about it without knowing in advance what you're going to be asking. So it's excellent for being able to determine trends in data or being able to find out, hey, in console, set up a database file and run queries on it. It's a full SQL database. It's small, but it works. Now, if you run this command that I've set up here directly without any preparation, then the query that you've written, the select star from users, is not going to work because that example.db file doesn't exist yet. That database doesn't have any data in it. But if somebody sends you an example.db that is set up to be a SQL database, and you can connect to it from Python, then that query will work. And you'll be able to execute any arbitrary queries you want. You can also create a file like that through Python. There are also projects called Object Relational Mappers, ORM. And they basically allow you to organize your data in a SQL table while simultaneously using your data in Python objects. So 2 very good object relational mappers are the Django ORM, which you might be familiar with if you've ever used the Django web framework, or SQL Alchemy, which is a standalone ORM and can be used with any web framework or without a web framework at all. It can be used to handle databases without using the web. This is an example of using the SQL Alchemy ORM. You define your data, and it looks, as I said, exactly like a Python class. And you can create an instance of that data, and you can actually save it to the database just by calling a save method. And as I've said, the database will handle things like giving your data a piece of an ID for you. So you can actually find out what that ID is just by asking the object. It's a nice Pythonic interface between a Python interpreter and a SQL database. You can also do queries in a fashion that's a little bit more Pythonic, a little bit more easy to understand if you're familiar with the Python world. This is the same query, the first one written in an ORM style, and the second one written using SQL. And you can see that they're similar to each other, and you can see how each different part of the ORM query relates to the SQL. But by building up a query this way, first of all, it's a little bit more familiar. And second, it allows you to do familiar branching in your code using if statements to decide if you want to join on this or join on that, to insert pieces of information into your query safely and make sure that you can run queries based on user input without the user corrupting your database. And you can do all sorts of other interesting things with it as well that the SQL Alchemy docs and the Django docs describe in great detail. So I think I'm about out of time. But I may have some time to take a few questions. I've put up a couple of icons up here of popular projects that are related to this if you're interested in learning more about it. In particular, if you're interested in learning more about how to get started with a SQL database, I highly recommend the PostgreSQL project. It's one of the most active, open source, and well-maintained, and highly featureful databases out there. So any questions?
So what size of data would you say it's worthwhile to not use SQLite 3 and just use a real database?
I'd say when your data starts to get bigger than about a gigabyte or so, you'd probably want to use a real database, something like PostgreSQL, and start moving away from SQLite.
To add to that comment, actually, SQLite is totally a real database. The thing that it's bad for is concurrent access. So depending on sort of the profile of the access, SQLite may be actually great for you in a lot of cases. But if you're getting a lot of concurrent access, then it immediately stops being a good database.
So what's the lookup time of SQL database versus NoSQL database?
Can you repeat that?
What's the lookup time of entries or joining databases or tables in SQL versus NoSQL?
The question was, what's the relative lookup time in a SQL database versus a non-SQL database? And that is a question that a lot of people have tried to answer, and everybody comes up with different answers all the time because it highly depends on the database implementation, depends on how you've tuned your database and got it configured properly or not, depends on exactly what sort of data you're interested in. There are benchmarks devoted to answering that question, where people will determine what's faster, this database or that database. In general, I would suggest that you work with a SQL database to start with, see if you can get it to work properly, because SQL databases are very, very fast. The only situation where you need to move from a SQL database to a non-SQL database because of speed issues is if you're dealing with maybe petabytes of data, maybe more. If you're going into that, then there are many better places that you can look for resources than me. But in general, in cases of mere mortal amounts of data, I would say stick with a SQL database to start.
Comment on that. I think some of the really big SQL databases would definitely disagree. It's not as much about size, it's more about kind of data storage. So when you're talking about unstructured data, which is really what the NoSQL kind of movement's about, that's where you really want to think about it. You're going to have really weird, basically, access patterns to that data. So therefore, the structuredness and the relationships that are in your SQL database, in a typical SQL relational database, don't work well. So therefore, you have performance issues, kind of searching and finding things or updating things. NoSQL is really when you really want to deal with kind of massively unstructured data, or you don't know what the structure is, you want to change the structure over time. That's where it really falls into it. I think, whatever the key one, Terabyte, is that what they're called? But there's a couple of really big relational database companies that, they start in the petabyte range and they cost in that range?
Sure. So basically, it's a complicated question and depends on a lot of variables. One more question.
Any other modules that typically go with SQLite?
SQLite itself is actually divided into a group of different modules. There's one that it comes with called the declarative module, which allows you to use your tables. Sorry, SQL Alchemy, my mistake. The declarative module allows you to use your tables very similar to how you might in the Django ORM, where you can just instantiate an object, as I showed you earlier, and call methods on it, and it works very smoothly. There's also another project called Alembic, which is made by the same guy who wrote SQL Alchemy, which is designed for database migrations. So if you have a database of one schema, and then you need to modify it to add a column, remove a column, add a table, whatever, Alembic will help you to do so in a way that is easy to replicate, easy to test, and makes you feel a lot safer about the whole deal, especially when you've got a production database. All right.
Thank you. One more point about relational databases. SQLite is really prevalent. It's in every one of your files, by the way. And every time you search for whatever in a browser, the history is being reading into a SQL database. Brian and Francis,
We're a couple slides.
Oh, okay.
who are getting familiarized with the phenomenon known as iPhones.
Yes.
It's
pretty cool, huh?
It is pretty cool.
Yeah, I'm going to get one.
Brian and Francis, as it happens, also work at edX. As do I. It's very clear what happens if you come to work at edX. I rope you into doing talks as often as Python. So, Brian and Francis, you ready to go?
Yeah.
Maybe give these people a sit. Get your drinks and take a seat. You're going to miss the good stuff.
So as Ned mentioned, we're going to talk about HTML and CSS. And I'm Francis.
I'm Brian. It's probably the toughest part of the presentation.
Yeah.
We are both designers at edX, as Ned mentioned. Design at edX. Sorry. Can everybody hear me? Mic free. Design at edX is all the traditional design stuff you would imagine, UX-y stuff, wireframe, sitemaps, comps, but it also involves the front-end development of things, so HTML and CSS. So we are the
Chop shop.
We are the chop shop / standardistas of HTML and CSS at edX. And we are also huge nerds. different flavors of nerds. I think Francis is more the cool one, and I'm more of the, I don't know, just weird nerd.
Batman.
Yeah.
If you want to talk elements, though, you know, either of us will do.
Yeah. So a couple things before we get started. Fair warning, I am known to drift off into metaphors and cultural references, so Francis will pull me back.
See how many you can spot.
Might be a prize. There's a lot of links and resources we're going to talk about. We've linked to them or referenced them throughout the presentation, but there'll also be a slide at the end of this deck that has a huge list for you, and we're happy to recommend other things if folks have certain interests. Some slide code is abbreviated, so we'll give you a heads up when we've missed a couple tags or changed things for the sake of fitting them on a slide. The slides are online, and we're pretty proud of this. We get pushed our demo code up, so there's actual demo code for the demo. That's a big thing for designers to do.
Push, pull, which one is it?
Which one?
So we're basically, as we mentioned, we're talking HTML, CSS. It's pretty introductory level. You may sort of know some things about one or the other or both, and hopefully we will reinforce the better things you know and maybe knock off some old knowledge or something. We're gonna, at the very end, we'll touch on some of the more advanced topics and current cutting edge stuff, just in case you want to take it a little further. And we're happy to answer questions at the end.
Cool.
Could you go back to where the slides are? I just need.
Oh yeah.
Sure. They're on speaker deck/talbs, which is my handle, so that might help you find them. You got them? Yeah. Good. Cool. So as Francis said, here's the agenda. We'll have some time for Q&A, hopefully. But to get started, to take a step back and to think about, for us, what it was like learning HTML and CSS, and to think about what it would be like now, the idea of A Tale of Two Cities came to mind. And it's a great time. It's the best of times to learn to write HTML and CSS now. Nice. Somebody's getting a prize. So they're out and they've been around for a while. There's been multiple iterations, and there's been huge committees and huge movements behind them. They've evolved, they've devolved, and then re-evolved. So they're pretty hard and steadfast, and there's some good principles behind them. There's lots of conventions, tutorials, and help. Back in our day, I don't even know if Stack Overflow was around or if we knew about it. But today there's a lot of great resources and a lot of good tutorials and a lot of good demos online. There's really good tools to help make your job easier. Everything from linters to things like CSS preprocessors and all those nifty things. We'll touch on those in a minute. And there's also Bootstrap and other libraries to get you going, like Foundation and a few other ones. And those are really nifty to at least get you into the code and start giving you some frameworks to start building some UIs. Now the other side of that, it may also be not the worst time, but not the optimal time either. There's a lot of new features with spotty support, so there's a lot of things going on with animations and transitions, a lot of new elements. So still learning that iPhone. No, I can.
Okay.
Thank you. More is expected out of folks who write HTML and CSS. There's a lot more abstraction that goes into it. There's a lot more when we talk about developing games. There's tons of devices and contexts, so iPhones, iPads, desktops, all different OSs. And then Bootstrap and other libraries can be great, but they can also be the cliff notes that don't let you read that whole book. You can pass the test of the cliff notes, but learning some of the concepts of the book or the principles, you won't get.
Yeah, they can easily be a lot more than you need to, so use them with caution.
Sound words. So to get started, let's kind of, let's focus on what HTML and CSS's job is in the first place. So it's pretty much to display all of the information and the visual layout and weight that support that information on a page. So this is a great example, not only because it's showcasing a fine animation series, it's well done and highly recommended, but it represents a lot of the elements you're going to come across and that we have to render day in and day out with HTML and CSS. We have headings, we have images, we have lists, we have buttons. We also have some advanced functionality like drop-down menus and video playing, and yeah, I guess ads too. We also have to acknowledge that there's a bunch of flavors of HTML. So who here has dabbled in, moonlighted in? Is that the past tense? Moonlit? Or wrote HTML as part of their job or just for funsies? All right, sweet. Who here has written HTML4? Sweet, kudos for knowing HTML4. XHTML 1.0 strict. All right. Last one, XHTML 2.0. That's a tough one. That was the
that was the dying point.
Well, that was the stickler. So there's tons of flavors. For our case right tonight, we're focusing on HTML5 and CSS3. They're the modern ones. They're a lot of what people are writing in now. A lot of support is being written for those. And the last thing I want us to just be mindful of and agree upon is the idea of being a bit rusty or knowing just enough can be a bit dangerous. And I guess to put you guys on the spot, here are some examples of things that I want to just kind of leave in the past tonight. So if we don't have to raise hands, but if you are familiar with any of these things or things like them, we're going to try to show you a couple of different ways to handle things like this. Cool. So where to get started? What's the thing? If there's one thing I'd like everybody to walk out of the room with, if they don't already know it or believe in it, is the main purpose of HTML and CSS, or the main thing to do to manage with both of them, is to keep them separated. One manages the structure of the page or the app or the view, and the other one manages a lot of the presentation. And there's a lot of benefits for doing that. So in this case, HTML is the structure. CSS being the presentation. And there's a third part of the Holy Trinity, JavaScript, which we're not really going to talk about right now, and I think there might be some folks in the room who are probably more qualified than us to talk about that. And we're getting hisses from the front row. So to talk about structure and presentation, when we tried to figure out how to explain this, and every time we try to get the meaning or the reasons behind this, one of the things I like to do is think about where else do we see structure and presentation separated. And Frances had a really good one when I asked her this question, so I'm just going to let her.
This is where my nerdiness comes out. So has anybody heard of the architectural duck? It's a building on Long Island that was just a plain old rectangle, and then somebody made a big duck outside. Another example, that it's kind of an architect, so this data center is another sort of architectural duck, but the outside doesn't quite reflect the structure of the inside. But the inside is structurally sound, one can hope. Solid, the rooms are functional, but the outside is different. You can present it in different ways. You can change the shape. You can make the duck a cat, and it wouldn't change the function of the building. So that's one of my favorites.
It would just be a cat building.
Yeah.
Right. And the way that I've always explained this, and I think I've tried to explain it to my mom at some point too, was I use the metaphor because I like to cook, and I enjoy eating cakes, is the idea of a cake, right? So you bake a cake, you get the actual cake out of the oven, and that's the structure, that's the actual content. You can provide whatever presentation on top of it to change its meaning. It can be a birthday cake for a 2-year-old, or it could be a birthday cake for a 40-year-old and they're over the hill, which is not over the hill these days, I guess.
Good budget.
Yeah, sorry. But back to HTML and structure. So how do you represent that more on the HTML side? So we don't have cakes, we don't have architectural blueprints. How do we define structure within the HTML syntax? So we're pretty much working with 3 different things: semantic tags, supporting tags, and attributes. And we'll go through an example that's a bit more easier to understand those than the duck or the cake story. So I don't know if folks are familiar with this or anybody has had one of these before, but I often get a honey-do list. Is anybody familiar with the honey-do list? So honey-do list is a list And it's great. It's helpful for me because I need an agenda. It's when my partner, significant other, needs me to do a bunch of things. This is a typical honey-do list for a Saturday morning. I need to go to the grocery store. I need to get those 4 things underneath the grocery store list. And then I need to do some yard work. And in the yard work, I need to do those things in that order because raking the leaves and then bringing the leaves to Home Depot just wouldn't work. So that's a typical honey-do list. You can see that there's a couple different groupings and you know, there's some organization there. So when we talk about semantics, we talk about thinking about the outline of that. I need to know what this list is first. Then I need to know what the sections or the parts of this list are. So think about it as if it's a book outline or maybe some cliff notes or a general hierarchical outline of what the content is meaning to communicate. So in this case, this is that same list marked up with HTML. So you'll see that we have some heading tags. This is the first time I think we're seeing some tags. So if folks aren't familiar, the tags marked in that nice green are wrapped around content. There's usually an open tag and a closed tag. In this case, the heading tags denote the different headings in the outline. And then we have a couple different lists here. We have an unordered list for the things in the grocery store that I really don't need to do in any order. I can roam around for hours. And then I have the ordered list down below for things that I need to do in that order for the yard work. We talked about semantic tags. There's also supporting tags. So the idea of divs and spans. Has folks thrown around a couple div tags here and there in their history? Yeah. So div tags are pretty popular. In our case, we want to use div tags more for supporting markup. So not so much any semantic richness that's meant to describe the content. It's meant to just break up the content into divisions. And the same goes for spans. They're more just kind of splints to break up something that we may want to do something with later or provide emphasis with visually, but there isn't really any semantic emphasis being placed on it. And the last thing we have when it comes to structure are attributes. So the idea is that you can further describe tags with attributes, which are more information about the tag itself. So you'll see that the Kashi serial I have, since I may not be familiar with it, has a link around it now, an A tag. And the attribute that makes it a linker, makes the link functional, is the href attribute right there, which links to the actual Kashi website. So that's extra information about the link. The other types of attributes that support us are more attributes that give us context when we get into styling or we get into making sense of our code later on. So the divs with the class of list. And same goes for the span with the class of preference. Anything to add?
No, that's good.
Cool. You wanna?
So this is the CSS part, the presentation. With CSS, you have rules that are made up of selectors that have properties and values within. One of the key things to remember with CSS is that it is cascading style sheets, which means the rules are processed in order, and the later rules overwrite the earlier ones. So if you write a paragraph and you say that you want it to be red, and then you write another rule down below and say you want it to be blue, it's going to end up blue because it will overwrite. Another thing to keep in mind is the specificity. So if you make a rule, you know, a paragraph within the content, that would be more powerful than just plain styling a paragraph. So let's look at what a rule looks like. So you can see we're kind of bringing back to the grocery metaphor again. So we've got milk. We're going to get the hood milk in a half gallon. Got eggs. Some of the values there are dozen, brown, doesn't matter, brand. And so this is what the selectors would look like. You've got the milk, then you've got the properties, brand, pasteurized, growth hormone, size, and then the value for each of those. At the top, you can see commented out is sort of a generic definition of that. So that's what a selector looks like.
No.
Okay.
Just a quick note that The previous selectors with all the peanut butter properties are not real CSS properties, just for demo.
You can give it a try though, you never know when it might work. And this is starting to reference our HTML. So you've got the H1 tag that will make the font size a bit big, give it a margin on the bottom, and you can some of the selectors together. So you're going to let you describe the image. It's really helpful for accessibility for anybody who doesn't load the image or is using a head. And that's where you define some of the meta, etc. Then it goes on ingredients, directions, source, and one. It starts with font size and then line height, and then it'll define in this case we just did a different color. If you want to talk about the other. There's other pseudo styles for links. Brian has a really excellent anagram for it.
Thing of media queries, which kind of query the width of the actual browser, which is a great starting point. So again,
in SAS, I was wondering if you tried any CSS preprocessors implemented in Python, and if so, how they compare to SAS.
Management heavy. I think there's some folks that might know some ideas. Maybe Mead Hall is a good time to chat.
One more question.
Yes.
I was just curious from.
And there is another shorthand.
The Ruby, I guess, side. So I've done a lot in Node as well. So like I've done a lot of APIs. I'm curious what it looks like on the Python side.
That's a big question. That is a big question. So the question is how do we continue to keep that separation of presentation and style even within Python and Django? I think for us, we've kept most of our stuff outside of that. We work within a lot of static directories that Django, for the most part, doesn't touch until it's time to, at least at edX, call the pipeline, and we then kind of manage what files compress into what. Some of the things we're learning about now are Django templates and more of that HTML side. There's a really good post up with that someone at edX just forwarded me this week about how to better abstract your Django templates. So that's something that we're learning more about with the Django templating, but for the CSS and SAS side, that's completely separate.
All right. Thank you.
Okay, you all have been patiently listening for the last hour and more change. Why don't we all at least stand up? Everybody, come on, please stand up.
There's going to be candy in the front counter.
So in 7 minutes, we're going to start.
7 minutes.
So before we unleash Jessica on regexes, we are going to Mead Hall in about half an hour, and there is going to be something there which is amazing, which is free beer. And the reason there's free beer is because Rue La La is buying beer for you, and Evan is from Rue La La, and he's going to explain it.
Rue La La. R-U-E-L-A-L-A. For those of you that don't know us, we are an online retailer in the flash sale space. Think like Woot or Groupon daily deal type site. Difference between Groupon and us, number one, we're profitable.
Zing! Oh, snap!
Number two, we focus on apparel, particularly high-end fashion. So that's who we are. Why are we here tonight? Because we love Python. We do a lot of our coding in Python. Number two, we love the community. We use a lot of open source. We like to give back when we can. We also have found a lot of several employees here who have joined us, and three we're hiring, just like everybody else. So, if you want to learn more, come talk to me afterwards. We're solving a lot of interesting e-commerce problems, scaling, elasticity. We'll be doing things like international expansion next year. Multivariate testing. What else?
Got any databases over there?
We do. MySQL, Oracle, for those that have a strong stomach. Ask them to look at our PL SQL code. A lot of it's 10 years old. We're trying to get rid of it. So if you want to learn more and you want to come help us do that,
that enjoyment. So we're going to write a lot of code that involves sort of matching patterns in words in one of the official Scrabble dictionaries. Do we have any Scrabble aficionados here? So we're using the Saupods dictionary. Hopefully that's okay with you. Okay? But the Saupods Scrabble dictionary is a huge dictionary. It has over 267,000 words in it. Basically, the people who are really passionate about Scrabble were like, as many words as we can get into that dictionary that we can get points for, we're going to shove them in there. So it's a huge dictionary for being able to score well in Scrabble. And I've written a teensy little library that will let you import this word list as a list of just lowercase words. So all of the words in the word list are in that Scrabble.wordlist list right there. And so we're going to write some regular expressions to pull out words with interesting properties from this Saupods Scrabble dictionary. Okay, so here's a warm-up question. What are all of the words that contain UU? Now, no points for vacuum. We know that that's one. Hint. Are there any other words? Maybe vacuum's the only one. Anyone? All right, so math term, maybe UU, hopefully it's in there, yeah? Continuum, okay, legit. Okay, let's see if there are any more. So one way that we could do this, in Python, string manipulation is already pretty easy. We can just use that in keyword for containment, right? So for every word in the word list, if UU is in the word, print the word. Cool, so we can do that. Well, okay, so we can do that. And we would run this script and we would see the output. We can rewrite this, exactly the same output, but using a regular expression. This is gonna be our first introduction to regular expressions in Python. It's gonna look pretty similar. So all I had to do here is we're going to import the RE, the regex module, and we're going to compile a pattern. This is the pattern is inside the quotes there, so UU is the pattern that we're going to match against, line by line. So we're going to go for every word in the Scrabble word list. If we find that pattern in the word, if that pattern matches a search for that word, we're going to print the word. So it expresses the same thing as the previous slide, but using sort of the regular expression framework. So why don't we go ahead and run this? All right, so here's our code. Save it. All right, so we've got, if I had two U's in Scrabble, I'm actually in pretty good shape here. Ultra vacuums, squished, Weltang Shangs. This stuff is gold. Moo moo, we could have come up with that. Okay, so we have a lot of UU words, awesome. But that was just sort of like a literal text match. So let's see if we can use regular expressions more to our advantage here. So here's a related but not quite the same question. Besides aardvark, what are all of the words that start with AA? Now we can always, well, so we can sort of imagine how we do this in plain old Python. You know, there's like a starts with string method, I think. You know, we could see if the first two characters are AA. But how can we do this with regular expressions? Well, going back to our same template from before, we have our AA. We know we need that. But we need to introduce a new character that's going to help us say, oh, but I mean start at the beginning. And the special character that means that is a caret. That's all there is to it. So we have our new regular expression that says all of the words that start with AA. We'll go ahead and run it. OK. So in addition to the aardvark, we have an aardwolf, multiple variants on arg, which, OK, fair enough. Like I said, these Scrabble players, it's like they're desperate. OK, so caret, good. You know, related question. OK, so we're going to keep track of our special characters here. So caret means the beginning. OK, more on boundaries, but about the end of a word. So I'm writing my first children's book. I got the first couple lines, 1 fish, 2 fish, red fish. And I'm going to need some help here with the rhyming part. And OK, oo fish, so oo probably sounds like ooh. What are the words that end in oo? OK, kangaroo, good, I like it. Zoo fish, OK, these are, you're going on the book deal with me. So we needed an expression for end of the pattern. So we have our oo, our oo, and the way that you say end is a $sign. See, regular expressions are easy. This is you just need to know a couple of characters and bada bing, bada boom, you're done. OK, so oo. Let's see if there are any matches. All kinds of matches. 1 fish, 2 fish, red fish, vindaloo fish. We're golden. Excellent. OK, so we've got our first two special characters. Broadening horizons here, because again, cheating at word games is very important to me. So, you know, I don't know if you're like me, you're stuck on the Sunday New York Times crossword puzzle, and you know, here we are. OK, I'm looking at 31 across. The definition is a break or pause, usually for sense, sure, in the middle of a verse. Anyway, I have no idea what that word is. So can I use programming to solve this for me? Yes, definitely. So again, just one new character here. Keep it easy. So we know that we have, let me see if OK. We have blank AE blank UR blank. OK, so blank AE blank UR blank. OK, well, as it turns out, the dot that we were using as a blank means any character. So this regular expression means, you know, any character, then AE, any character, UR, any character. Let's see if there are any matches. OK, we have a lit major in the room. Fair enough. OK, so we have a couple of variants on caesura. Excellent. Now, interestingly, we have sort of the first one, and we have a couple of longer ones. And the longer ones wouldn't have fit in the crossword entry, right? Like, we have only a certain number of spaces. So what would we do to eliminate these other words? What have we already learned that we could use to eliminate these other words? Yeah. So we say, OK, well, it really does need to start with that wild card and end with that last wild card, right? OK, save that. Run it. There we go. We don't have to know anything to solve this Sunday crossword. Excellent. OK, a couple more related questions. First, what are all the valid two-letter Scrabble words? You know, this is key, right? Because when you're getting desperate at the end of the game, you really need to know all of these two-letter words. So how can we find those? We've got all the tools we need, right? So two-letter words. They can be any character, so dot, dot, right? But we know if we just did dot, dot, it would be any word containing at least 2 characters. So we'll add those anchors as well, the beginning and the end. Save this, run it. Lots of them. This is just crap made-up words, but they needed something to play when they had only a Y and a U, so there we go. So related question, which is going to force us to think about sort of, you know, a broader range of problems here. What if I wanted to know all of the words that start with an A and end with a Z? Start with an A, end with a Z. Well, we sort of have tools to do this already, right? So we could do this kind of manually. We could say, okay, well, if it starts with an A and it ends with a Z, and there's one letter in between, like, are there any words that have that? Very good, I heard that, excellent. And then we could say, okay, well, are there any with 2? And we could save that and run it. And apparently no, but maybe 3, and run it, and there are a couple. But I mean, that's super manual, right? Is there an easier way of expressing this idea of sort of an arbitrary number of wildcard letters in between? Yes, there is. That dot, that means any character. Bam, put a star. That means 0 to as many as we need of a wildcard character. So A, and then whatever we want, and then a Z. Dot star. So let's see what that gives us. There we go. So you got the A, you got the Z, all of the words with whatever you need in between. Cool. Okay, so more wildcards. And so at this point we have 4 things we've considered here, those anchors and then these wildcards. Okay, trickier questions here. What are all of the words that contain only vowels and Y? Because if this is your rack, we're going to need to know these. Okay, that contain only vowels and Y. Well, we can use an idea called character classes to express this concept. So let's see what that looks like. Okay, so we have the vowels A, E, I, O, U, and Y. And if we put them in brackets, that means any of the available characters in that character class. And we want this as many times as is necessary to spell the word. I hope I'm not typing anything. Here we go. OK, so A, I, O, U, Y, any of those words for the entirety of the word. Star for as long as the word is. Let's see what we get, if any. OK, excellent. So this one, that's definitely a back pocket word in case you're in that situation. Excellent.
That's a word?
Exactly. So related question, are there any words that don't contain any vowels, not even fake vowel Y? This is super easy to express. So the caret actually has 2 meanings. So we already know that it's an anchor meaning the beginning of the word. But we can also say caret inside the brackets for a character class, and that says negate. Don't include any of these letters. So just by adding that caret, we go from only vowels to no vowels. So are there any words that contain no vowels? They're words-ish, I would say, but they're definitely valid Scrabble words. Great. OK, so we answered both of these questions. While we're playing with this, might as well ask, what is the longest word that can be typed with only your left hand on a QWERTY keyboard? Any trivia buffs know this? Oh, he's thinking about it. Not according to what I ran. We'll see. OK, good guess, though. And again, how would we do this? Well, if we wanted to, we could just, using that character class as brackets, list all of the letters on the left side of the QWERTY keyboard. The result, according to my analysis, is sweater dresses. Do we have any ecologists in the room? Yeah, OK, so in case you were wondering, so the right-hand side of the keyboard, so the corresponding only contains the right-hand side of the keyboard, is hypolimnion, which is the dense bottom layer of water in a thermally stratified lake. Yeah, good to know, right? So character classes, those square brackets. A little bit more on character classes, and I'm gonna, please take a look at that picture. I photoshopped this for you guys. So it's pretty sad. The human, I was so far away from the human on the list of character classes in terms of heights that I couldn't even fit the human on the slide.
Joseph, you were just pointing at yourself, pointing at a screen.
It's true. We're getting pretty meta here. That's pretty serious. OK, so more on these square brackets. You can express ranges of characters, because that's a really common thing that you want to do when you're writing regular expressions. So let's say that I wanted to match everything A through C. You could say that by just saying A hyphen C. It means A through C in the alphabet. Other really common thing is how about all the lowercase and uppercase letters? A to Z, capital A to Z. How about all the numbers, 0 to 9? You know, if you wanted to do all of the, like all the hex characters, how would you do that? You could say A to F, 0 to 9. Yeah, exactly. These are so common they're even shorthands for them. So instead of having to sort of spell out 0 to 9 every time, you can actually use these shorthands. \D for a digit, \S for white space, and \W for alphanumeric characters. Pretty cool. And a tip on this, honestly, I have to look up which one is which every time. But if you can't remember this tip, the uppercase version of the shorthand is the reverse of the lowercase. So like \W is alphanumeric, capital W is non-alphanumeric. It just has, and it literally is that expansion with the caret doing the negation inside the character class. Okay, so we're building out our list. Pretty good, pretty good. Any questions so far? Excellent. Another really common idea is repetition, wanting to repeat something m times. So if we wanted to match a phone number, we could do the above, you know, \D, 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 or we can more succinctly express that using this curly brace number instead for the shorthand. You can say repeat m through n times. So if you wanted to match a username, let's say you're building a system of usernames having between 3 and 18 characters, you can use that \W shorthand for alphanumeric and the restriction that it has to match 3 to 18 times. Cool. You can also, just like with Python slicing, you can leave off the bound. So like if you left off the thing after the comma, it would say m to infinity times. That's kind of cool. Then also about repetition, if you want to say that something has to happen at least once, you can use a plus sign. So like let's say I'm writing some blogging software and I generate a unique URL for each post based on the first couple of words in the title. This is often called a slug. There has to be at least something in the URL. You need at least one character in the slug that makes a unique URL for the blog post. And maybe the restriction on that slug is that it has to be lowercase letters or numbers or a hyphen. And the way you would say that is with the bottom regex. So adding to our list, so curly braces for repetition, plus for 1 or more times. And there's also a question mark, which means 0 or 1 times. A really common case for that is, let's say that you're matching URLs. You want to match things that are HTTP or HTTPS. So that S may appear 0 or 1 times. So question mark for that. Okay, so we're really good at matching things now, but what if I actually want to know what I matched against? We so far haven't seen that. It's been just sort of a did I match or not. So we need to figure out how to reference matches in our regex. And there are a lot of ways to do this. So this is going to be sort of a survey so you know what tools are available to you. So let's say that I have a bunch of text and I want to pull out the phone numbers from that text. This is not my real phone number, by the way. So we compile this pattern, similar to the ones we've seen before. The \D is for digits. It's 3 digits and then a hyphen, 3 digits and then a hyphen, and then 4 digits. Well, here's the first option, which we haven't seen before, but I want to mention it because it will come up in the documentation. The first is pattern.match. We've been using pattern.search previously. Pattern.match is the same thing, but it starts at the beginning. It only matches on the beginning. So it's just like you had that caret leading anchor implicitly in the match. And in fact, there is no match in this case because there is no digit at the beginning of the text. We have our search from before. And this is what it spits out. If this is the result of matching on the search. And then we can pull out the matches with this group method on the regex match object returned by searching. So that's one way to get it out. Well, sorry, that's one way to get the first one. Because search is going to find you the first match in your text. What if you want all of the matches? Well, there's an app for that as well. Find all will get you a list of all of the matches. And there are even more ways to do this, but depending on what you want, if you want the first match, if you want all of them, use the tool that's appropriate for the job. You can even name references. And if you use Django, Yeah, lots of people use Django. Yeah, and in your urls.py, if you've seen a bunch of these weird things with the question mark and the p and these things, what are these? Angle brackets. And you're like, I'm just pattern matching here, but I'm sure it's important. That's what these are. These are named references to the matches in your regular expressions. So what you can do is you can provide a name which is good for readability and for pulling out parts of a match if you have sort of many things that you're matching at once. So in this case, we want to match on some important stuff in a URL. And the first thing we're going to match is that \w for an alphanumeric string between 6 and 18 characters for a username. And we're going to call that username. So we're going to be able to pull it out using this description later on when we're pulling out our search results. We're also going to match a slug again. So again, it's this alphabetic or hyphen, and it has to be at least one character in the slug. That's what the plus sign is for. We're going to call that slug. So question mark p and then name in angle brackets is how you name a grouping in your regex. So if we do this, now we can pull it out in a couple of ways. So there's this groups method, which will spit it out to you in an ordered set. Or we can pull it out by name, which is really helpful for readability, right? Because you want to make sure, if you want to remember what you were doing 6 months from now, this helps you keep track of what is what. So cool, named references, very helpful for readability, and you see them all the time. Again, check out your Django urls.py next time you look at it. These are all over the place. Okay, so adding to our special characters, excellent. Oh yeah, so second from the bottom, the parentheses here are important. So the parentheses bound the thing that is a potential match. So we have two sets of parentheses in this example, one for the username and one for the slug. Okay, so we have references. And that's helped us to express a lot of really interesting stuff, matching things. You could imagine using this to match in URLs, matching people's Twitter handles, matching all kinds of things. One thing that we haven't totally covered yet is, what if I want to know if there's like a set of characters that gets matched repeatedly, or like it gets repeated? How do I capture this idea that we were matching something that we've matched before? So like if there's a name that also shows up later in this sentence, how do I capture that idea? So we can use back references for exactly this concept. So it's easy to see with an example. So let's say we have some text here. The lazy brown dog went to sleep. And what we want to know is there a character that is ever repeated 6 or more times in that text? So a particular character, so like given a character, it is repeated 6 or more times in that text. So first we have to match on a character, like any character, a wildcard character. We know how to do that, right, with a dot. But then we have to be able to say, okay, given that character, like given a z, are we matching it 5 more times? The way you say that is with a \1, which is the reference to the 1, which is the first group, the first thing in parentheses. So \1 references the first thing in parentheses. And then we know that curly brace syntax already, right? That means match it 5 or more times. So given an arbitrary character, do we match that, again, 5 or more times? And in fact, we do in this example, right? Because we have 6 z's there. We have this r thing, which is a little bit weird. Because of that \1, we need a special string type to correctly interpret the \. So I don't know if you knew, Python has another type of string in addition to the other types we've seen before, like a Unicode string. The r is a special string type for regular expressions, at least in Python 2. The story isn't free. Cool. So a slightly more complicated example. Are there any words that have the same letter 7 times? I don't know what letter it's going to be, but it has the same letter 7 or more times. Does anyone have a guess? This would be hard. All right, so let's go back to our prompt and see if we can figure it out.
Do you mind moving your mouse a little to the left?
I'm sorry?
Do you mind moving the terminal, window? It sounds arbitrary, but trust me.
Okay, sure.
Perfect.
Sure. Okay, So we need, okay, what do we want to do? We need an arbitrary character. Does it match 7 or more times? Well, we already saw how to do arbitrary character. It's this, right? Oh, let's not forget our R, because we're going to use back references. So we have an arbitrary character. There can be anything in between it and the next reference. So that dot star can be anything between it, anything or nothing in between it and the next reference. And then we pretty much just keep repeating that until we have 1, 2, 3, 4, 5, 6, 7. OK, match any character 7 times. Let's see if there's anything. Pretty good. Classlessness. Successlessness. OK, but definitely, if you have a lot of S's in Scrabble, this is good for your back pocket. All right, so back references. And this is actually, we're getting into some pretty serious regex stuff at this point. I'm going to argue that between the things we've covered, boundaries, wildcards, character classes, repetition, references, and back references, you're going to be able to express pretty much anything that you need to express using regular expressions. And you can look up the other stuff that you need. As I mentioned earlier, there are regexes all over the place. I grepped through my site packages for re.compile, and here are a couple of the examples that I found. So these absolutely happen in the real world. We even know what these mean. So the first one, from Python Markdown, is going to match, well, you tell me, what does it match? Exactly, right? So first it matches either an uppercase or lowercase h, and then a 1, 2, 3, 4, 5, or 6, so these character classes. And this helps match HTML header tags, hey, tying it back to the previous talk, excellent. In Jinja, this is kind of cool. It's doing its best to match a number. So a minus sign for maybe if it's a negative number, and then /G for it's a digit, 1 or more digits, and then a dot, and then 1 or more digits for a floating number. And in SQL Alchemy, a simple date match. Pretty good. If you ever feel like you're getting lost while working on regular expressions, it can be really helpful to use one of many online visualizers that will help you sort of pictorially see where the loops are. Here's one that's pretty cool, regexpert.com, and it will, as you're typing things out, it'll show you a visual representation of the repetitions. So that's cool. So what's next after this talk? Well, in addition to sort of practicing the Python specifics, regexes exist in Python, but they exist all over the place. So for example, a ton of the Unix utilities that you may use day to day, grep, find, all of that stuff, they all speak regex as well. And you can use them to do elaborate searches on your file system. A lot of the tools that you use know how to talk regular expressions. Think about code that you've written. Are there places where often if you're not using regular expressions when you should be, there are like really big for loops with a lot of edge cases that you're trying to handle and it gets really complicated. Think about, do a sort of a mental code audit. Are there places that would be made much more robust by switching from a bunch of manual processing to a much more expressive regular expression? And then last but probably most important would be the next time that you are going to play Words with Friends, you should definitely use regular expressions to your advantage. The McKellar household is a little bit unfair because my dad likes using the internet to cheat at Words with Friends, and I like using programming, which is a true story. Like we play Scrabble and we play Words with Friends at home, and he will pull he'll pretend that he's going to the bathroom, and he'll go and he'll pull up the 2 and 3 letter Scrabble words on his computer and be remembering his rack and looking them up and which ones he can use, and then he'll come, oh, I was just in the bathroom, no problem. Of course, I mean, if you're going to do that to me, I'm going to cheat harder, right? I'm going to write a program to do this for me. So Christmas break coming up, holiday season coming up, Words with Friends, family, it's an excellent combination, so think about it. And that's really it. We've covered a bunch of really good stuff here. You totally have a solid foundation to go out and learn more and use them effectively in your code bases. You don't have to use regular expressions everywhere. Don't try to overcomplicate situations where a simple string match using plain old vanilla Python will do. But regexes are a really powerful cross-disciplinary tool in your toolkit, so I definitely encourage you to think about using them when appropriate. that's my pitch to you today. So thank you. Are there any questions? Yes.
R string.
Yes.
Is that really just for regular expressions?
Oh, I don't know. Raw, exactly. R for raw and for regex. No problem. Good point, thank you.
So you show us that you search for the longest word on the left side of the keyboard or right side of the keyboard?
Yes.
What's the method? Is there an easy method to just tell regex search for the longest word? Just fulfills that?
Basically, no. I mean, you can use, depending on what exactly you're, so the question was, like, is it easy to say longest of something? And it depends a little bit on what you're searching for. And you have these notions of repetition. There's this notion of greedy versus non-greedy matching, which we haven't talked about, but you can look up, which says, should I try to greedily consume as much of the text as possible with a match or not? And that, depending on what you're looking for, that may impact the results. So sometimes this is a case where using a for loop is a good idea and a readable way to do it. A couple of other thoughts here. If you're dealing with like non-ASCII, if you're dealing with Unicode, you might want to do a little bit of research on how regular expressions play with that. If you're dealing with, if you want to be matching across multiple lines, you can do that, but you need to tell Python, you need to tell the RE module that you want to do that. So there are various caveats in sort of when you're doing this day to day that you'll want to look up, maybe read the official Python tutorial. It's short, it's good. Yeah, there's more to learn, Other hands? Yeah.
How could you do a regex, for example, that lists all the words that contains exactly 2 A's and 2 B's?
Oh yeah, so okay, that's a good question. So the question was, how do we find a word that contains 2 A's and 2 B's? I don't want to be put on the spot. So the reason why this is interesting is because the ordering doesn't matter. So I would have to think about it, and then maybe
2 regexes.
2 regexes, yeah, exactly.
How do you combine them?
You check the string and see if it matches both.
In general, where ordering doesn't matter on things, that can be a case where things get more complicated to express in a regular expression than not using one. But do you know offhand?
Is it a parentheses A or B twice?
It's definitely true that regexes can't do everything you want to do. And just as an example, the most popular answer on Stack Overflow is about parsing HTML with regexes. And you should definitely go look it up to find out why it's so popular.
It's a descent into madness. You should definitely look. That won't. Yeah. Yeah.
I'm pretty sure you can do that example of the 2 A's and B's. You have to take advantage of the fact, and this depends on the dialect of regex. I believe Python allows the vertical bar to allow alternatives.
Yeah, you can definitely use alternatives. I think he wanted exactly 2 of each, and we'll whiteboard it afterwards. I'm sure it's possible. It's a question of me coming up with it on the fly. Yeah, okay. He's got it. We'll hook you up afterwards. Excellent. Other questions? Yeah.
How much time savings do you get with the compile thing?
The question was, we've been using this re.compile, and you don't have to use that. You can actually just sort of match things directly. I would hesitate to, and the question was, is re.compile substantially faster or not? I'd hate to say that without benchmarking, but certainly if you're doing the same lookup over and over and over again, like with these 260,000 words, it definitely makes some impact.
I'm going to contradict Jessica. All of the methods take a string and they will compile it for you and cache it. So if you use the same string more than once, it will find a cached compiled regex for you. It'll only cache 100.
Boom!
Boom!
So it's still
your program
compiled.
has 100? Yeah, now what?
We'll run some benchmarks. We'll do that on Pound Boston Python. If you're not with us on IRC, you're definitely missing the party, so join us. One more question? Yeah?
I guess the HTML thing gets in this direction. But I was curious, at what point do you have any advice on when it's worth switching from regexes to just writing a parser?
The question is, when do you switch from regexes to writing a parser? It's whenever you do an analysis and you think about which one's going to produce greater long-term code clarity, which you'd have to, being the smart programmer that you are, you would sense that based on your intuition and experiences. I don't have a concrete answer for that. Yeah.
One definite limitation of regexes is they're not good at parsing nested structures, which is why HTML is difficult to pull out. So if you're going to be doing something where you have the same structures nested again and again, regex is not up to that.
Excellent.
And by the way, when you write the parser, you're going to write it using regexes, but a whole bunch of them.
This still pays off. Yeah. Last, final question, if there is one. Awesome. Okay. It's 9 o'clock. Thank you all so much for coming. Awesome. Thank you again to our sponsors. And
Rulala and Red Hat.
Rulala and Red Hat. We're going to, okay, yes, clap for ourselves, yes. Yay. And them, yes. Thank you to the folks who, so this has been recorded so for posterity and maybe also live streamed.
Yeah.
Awesome. So other people can witness this too. Thank you to the fine folks who have been doing this for us.
Right, from
Custom Made. Awesome. We're going to be sending a coalition to Mead Hall shortly. It's just a couple of blocks away. If you want free beer and to talk more about Python, definitely follow the gang, or anything else, definitely follow the gang to Mead Hall. Thank you again. See you after Halloween. Woohoo!
Do you have that Daghon link somewhere?
Oh yes, I'll put the slides, I'll link to them